Hello, I'm Mr. Duda with STEM with Mr. Duda. Ignore the thing popping up on my screen. I have a Zoom meeting running in the background. I have an Arduino starter kit series, and I'm on project 12. If you haven't done the other projects, they really build on each other, so you might want to start at the first one. But this one is really cool. The last one I did was an LCD screen that was a crystal ball. You'd shake it, and it would give a random answer, like a magic 8 ball. This one might be even more fun. And the funny thing is, I came across it on YouTube. I didn't even know it was part of the starter kit, and it's just so cool. So it's called Project 12 Knock Lock. Make your own secret knocking mechanism in this project. A piezo buzzer usually creates vibrations, but this time you will use it as an input to detect how many times someone knocks on your door. You can take things a step further and automatically open a box with a servo motor if someone knocks the right number of times. So I will also link in my description the video of where I originally learned about this, and it's absolutely amazing. So check that out after this video, or you can check it out now and then come back and I'll show you how to make it. Okay. As always, I'm doing this through Tinkercad. You can do it in person with a real Arduino. The way I got here was I went to tinkercad.com. I logged in. I clicked on Learn. I changed this to drop down to Circuits. Went over to Projects, Show All Arduino. I've made a video on every single one of these green background ones, all the way up until Knock Lock, and I will work on these hopefully in the next coming weeks. So Knock Lock is what we're working on. You click on that, and then we will start by just clicking Start. As always, I will not read through all of this for you. You can read it, I know. So I'm not going to waste your time. This is an Arduino. This is a breadboard. There are input-output pins. You can connect wires here to other things here and put components over here and program it to interact with different things. Read through this, please, please, please. It will give you a very good understanding. The components we need is a push button, a piezo component, 3 LEDs, 3 220 ohm resistors, one 10 kilo ohm resistor, one mega ohm resistor, one, I believe that would be picofarad capacitor, and one servo motor. All right, if you bought the kit, it's already there for you. Okay, all right. So let me move forward. Obviously, read through those. It will help in your understanding. I'll show you how to set it up. If you're doing this in real life with an Arduino, follow the same exact steps. All right, first we need to wire our positive and negative. They are running it to the other rail as well, and we're doing 5 volts. So we run a red wire. Maybe I'll keep it, I'm going to organize it this way. Keep it red. The reason why is red needs to be positive. That if there's a red wire, that means it is positive. That's how wiring diagrams should be. So it helps us to stay organized. And then this entire thing is positive, and then we're going to run it over here to make that one positive as well. So then this entire thing is positive. Then we need a ground, which is black. Okay, they ran it over here. I like that one because then you can keep it nice and vertical. We make that a ground as well. So now we have both of our rails. This rail is positive, negative, positive, negative. We're going to be hooking up a lot of components this time. Moving forward, we're going to attach our push button. So we're attaching our push button. It runs positive through the push button. Then when we push the button, some of it will bleed off, be grounded. This is a voltage divider resistor, I believe. And it makes it so not too much, maybe a more steady voltage runs to the input. That one I'm not 100% sure on, but we put that resistor there so the full voltage doesn't go through there because I think it cleans it up a little bit, okay? Let's go ahead and set that up. So you can drag your push button. This one, it was running to a ground with a resistor. We'll fix the, to the ground. We'll fix the resistance in just a moment. And then this side was positive, and we want to make that red. Now remember, if we're looking here, it says a 10 kilo ohm resistor. We figure that out by looking at the colors. If we're doing this in real life, as long as it matches and it's brown, black, orange, whatever color that is, gold maybe, and we match colors, so that will work. Moving on. Basically, this means if we push this button, electricity is then going, is then going to flow through, good thing I looked, is then going to flow through this wire to number 2, so the Arduino can read, hey, someone pushed the button. Moving forward, we're going to put our piezo speaker, and it's going to be connected on 6 and then 11. So let's just do that. We can search piezo, 6 and 11. So I have 6 and 11. And the way it's working here is we are bleeding off, just like this one, right? We're running a resistor. Oh, in this case, we're just running a resistor, possibly to set it up so it can better detect the noise. This resistor slow down the flow of electricity. So we have positive running to 11 and then a resistor to ground. So we have positive to 11. It doesn't matter which one it's running off of. Those are all positive to 11. We make it red because it's positive. We add a resistor to slow down the flow of electricity. Maybe that's just to change the tone. If you need to rotate this, highlight it and press R. All right. And then we are going to run it there. And then these are all connected. So then we run to ground. Make it black so we know that it is running to ground. Now electricity will flow through here, through the speaker, through the resistor, and then to ground. All right, just a moment. All right, so moving forward, make sure you keep those colors right because this is going to start getting a little more complicated. We have LEDs in here. Okay, and each one of these LEDs do a different thing. So the colors are pretty important because you want to be able to identify exactly what it's telling you, okay? But if we look here, there's nothing new on this side. It's just the LEDs with the resistors and then running to inputs, okay? So let's get those LEDs. We start off with a red one and it's going to be on 4. So it's going to be on 4. Now I realized, oops, I hooked this up in the wrong one. Let me clean that up for you. I apologize for that. It would have worked, but it would have been more complicated for the wiring. So I'm sorry about that. You probably caught that. Once again, let's go back. It's going to be on 4, 11, and 19. So we've got this going to 4. Put it right at the top. 11. And yes, I said colors matter. We can change those colors on this. So this was going to be a green one. So just change it to green and change this to yellow. Then we put our resistors. And if you look, they should all be 220 ohm resistors. We are having, I guess we could run it this way. Let's do our positives first. So 5 is going to run to 9. Okay. So let's do that first. So 5 is running to 9, and I'll walk you through what it's doing. Make it red. That means that that's going to be an output. Electricity is running out. Then we have 4 running to 16. 4 running to 16. Make sure it's red. Electricity will be running out. This is an in. These are out, at least according to the colors. So hopefully that matches. And it looks through it. That looks like it is correct. 3 to 24. 3 to 24, make sure it's red. So now all the reds are positive, okay? Now we need to add our resistors. Now remember, the easiest way, we hit R to rotate. I think we can copy these. Let's go ahead and see if we can save some time. I'm going to press Control-C and Control-V. Yes, we can. And so then we can get our 3 resistors. Now, to save some time even above that, we can make sure that they're the correct resistance before we copy it. So if we look, we need a 220 ohm, not kilo ohm. So change this to ohm. Change it to 220. Now, if you're doing this in normal life, you need to find matching colors. I'm going to press Control-C, Control-V, click, Control-V, click. Now we have our 3 resistors, and they're going to connect to the right side of our LEDs. Now, if I'm looking at that, that is the anode. If you're connecting these in real life, they are directional. Diodes are all directional, and it's very important to make sure that we connect them the correct direction. Now, please look it up. Right now, I don't. Actually, here, let me look. This is how I would look it up, okay? I would go to Google, okay? And I would say LED anode cathode, right? And then when we're looking, what we can see, and this is, right? So the long side is positive. The short side is negative, it says, okay? According to this picture. Now I would double check that, and we double check and we would see the longer leg, let me get my picture out of the way, is an anode. And if you don't know what an anode is, you can look here, and positive. So the longer is positive, the shorter is negative. So when we're hooking these up in life, the longer one should be on the positive side. If you run this and your LEDs won't light up, just flip the direction, okay? All right, then the last thing that we need are grounds for each one of these. So we're going to ground each one. Make sure it's black. Ground it. And I'll talk you through what we're doing, why this is the way it is. Black. Okay, so I already talked about the button. I already talked about the speaker. In this case, what we've got is we've got our LEDs. Electricity will run out of these pins through the resistor, through the LED, and to the ground. The resistor is there just to maybe, I originally thought it was so it didn't burn out the LED, but some people have told me that it's to make a more consistent voltage through the LED. I can't 100% tell you, but I'll tell you right now, some of my LEDs have burned out without those resistors from students using them. I would definitely put the resistor in there. If you have more input, share down in the comments. I'd love to get a conversation going with that. Moving on, we need to attach the servo. We've used servos in here before. If you haven't done that already, we're probably going to use the micro servo. I'm going to bring it out. Now, they have it flipped around, so I'm going to flip it around just so it matches. Highlight it, press R until it is lined up correctly. I'll zoom out just for a minute. Then when we look here, what we have is we have the center connected right here, which then runs all the way to 9. Now, I would think you could run this directly to 9 instead of through the breadboard, but perhaps they're going to add something else. So they have positive running to the right side, negative or ground running to this side, and then this running to 21. So let's go ahead and do that. I'll do that one first so I don't forget. This one's running to 21 and then to 9, and they had those gray. I think that's a great idea to make sure that the wires match. All right, maybe we'll be adding something in there. You can drag this once it's connected if you want to better organize it. And if we look, this says power and ground. So we know that this one runs to the power, which should be red, and this one runs to the ground, which should be black. Right now, it looks like this would be giving the signal to turn the servo. That's going to be to unlock your lock, which is pretty cool. Moving forward, let me double check and make sure I got everything. Yep, okay. Moving forward, now it says attach the servo. Okay, they just wanted you to plug it in. In this case, we had it. If you have a servo that for some reason is set up differently and you'd have to plug the servo straight into the breadboard, you might have to do your wiring a little bit, but all my servos look like this. It actually has wires sticking out of it instead of this, so I just plug the wires in where I want, okay? Moving on, decoupling capacitor. Let's read that one. Finally, place a 100 picofarad capacitor across the power and ground terminals of the servo to smooth out any irregularities in voltage. All right, basically, and I'll show you, let's put it in and then I'll talk about it, okay? So capacitor. A really good example of a capacitor in normal life, and I'm going to rotate. So strange. Okay, I guess you can just run a wire from this. In normal life, you're going to have to maybe plug this into your breadboard and run the wires, but apparently we can just connect a wire, which that's good. So I'm going to connect to the positive, make it red. I will get back to what I was just saying about capacitors. A wonderful example of capacitors is a camera flash. It's what it does. Think about a disposable cameras for those of you that have used one. When you take a picture, then you hear that really high-pitched noise. If your ears are good enough, you'll hear the high-pitched noise as the capacitor's charging. Okay? What it's doing is it's storing a large amount of electricity. If I just like touched both terminals together, all that electricity would come out almost instantaneously and make a very bright spark, and it would light up our flash. Now, another way we can do it is it can store energy when electricity is running into the servo to get it to move. If it ends up like not having enough voltage for a quick second, it'll actually bleed off some of the electricity from this capacitor to power it so it's nice and smooth. People will put this in their sound systems in their cars. So if they've got like a lot of bass, you know, those cars that just shake the whole neighborhood, sometimes it's going to draw, it needs a lot of electricity for a split second to get that speaker really moving. And maybe the battery doesn't have enough energy. And so to improve that, what they do is they put a really large capacitor in there. So at that moment that it needs more electricity, it has that more electricity to grab from the capacitor. All right. So right now, the only question I have is this piezo. Now, I must have missed this, and it's funny, and I'm glad that I saw that. Yeah, maybe you guys caught it a while ago. Very strange that we didn't add it in there. If we were reading through it, it would have made more sense, and I'm glad they have it. I totally missed this one. I knew that something had to be there. If we're looking, and they did not, maybe it was described in the last one, this piezo it's going to be sensing something. It has to send information. So it's actually going to go to one of the analog input pins. So as we knock near the speaker, it's going to vibrate, okay, creating a little bit of electricity. And that little bit of electricity is going to be sent through this to probably analog 0. If I go back, maybe it says it. Yep, to analog 0. See, they didn't have it, but analog 0 runs here. And what happens is when we knock on this, it will sense the electricity, sending the signal to that. So now let's move forward to our code. Okay, as always, I go to create.arduino.cc. I click on Web Editor. You might have to log in. I think I did log in. On the left side, click on Examples, scroll down. This sometimes takes a little bit, and I'm not sure why that is, but on the left side, you're going to scroll down to Starter Kit, Basic Kit, and then scroll down, and we're going to choose Knock Lock. I'm going to copy all of this. I'm on a time crunch, so let's see how this goes. I'm going to move my camera over. Let's click on Code. I'm going to erase this. The reason why I use the code is because it has the notes in it. So we are going to use a library called myservo, which I talked about in another one. It gives the information how to control a servo. Then we're going to name our pins. We're going to name A0 in our code piezo because it's connected to the piezo. We're going to label number 2 switch pin, 3 yellow LED, 4 green LED, 5 red LED. If I'm going too quickly for you, going through those other lessons will really, really help you to better understand what's going on here. All right. Basically, we're just naming it in our code. Every time we write piezo, we'll be talking about A0, okay, and so on. Now we name a variable called knock value and then switch value to use later in our programming. We create something called quiet knock. We make it equal to 10. It says these are the variables for the high and low limits of the knock value. And then another one called loud knock equals 100. That should make sense later. And then we are creating a Boolean. Let me show you this. If we look up Boolean, and I really like to, when I'm doing this, I always search Arduino. The reason why is they have some really good information in their reference. So if we're looking here, Boolean is a non-standard type of alias for bool defined by Arduino. It's recommended to instead use the standard type bool. And if I click on bool, because apparently that's what I need to do, it holds one of 2 values, true or false. So it's not holding a number, it's holding a true or false. And I think that can also be 0 or 1, 0 being false, 1 being true. And we're saying, is it locked? No, it's not locked right now. And then how many valid knocks you've received, and it's going to count the number of knocks. Now, maybe that makes sense, maybe it doesn't, but maybe once we get into this programming a little bit, it'll make a little more sense. So we are going to say this runs once. We're saying, hey, we have run the library of my servo, and it's attached to number 9. So we have it attached to number 9 right here. And then make the LED pins outputs. So we're saying the yellow, red, and green, which we identified the numbers up here as 3, 4, and 5. So we've got 3, 4, and 5. And we're going to say they're all outputs. So electricity is going to be sent out. And then we're going to say the switch pin, which we already defined as number 2, that is an input. All right, it's going to receive information if this button is being pushed. Then start the serial. So the serial port, so we can actually see the values that are being read on A0, I'd imagine. And then it says digital write, green LED high. So when this turns on and everything gets going, the green light is going to be lit because high means electricity is being sent out. It'll be on. Then move the servo to the unlocked position. So when we turn this on, it unlocks the lock. Now, is that a good decision? I don't know. If I was using this for security, which it's probably not extremely secure, but I would want it if it restarted for any reason for it to be locked. But in this case, they're leaving it as unlocked. That's fine. Where am I? Okay. Then print the status. And so it will say the box is unlocked. Now you could add an LCD screen. You could totally do that and use the programming from the last thing that we did on Crystal Ball. You could use that, and instead of just printing it in the serial monitor down here, it would actually say it on the LCD. And then, so that's what runs when we started. Then we need to run a loop, and this just keeps going and going and going. So it's saying if the box is unlocked, so if locked equals false, so if it's unlocked, then read the value of the switch pin. So you're reading the switch pin. Remember, if we look up here, the switch pin is number 2. So it's reading this, okay? So read that. If the button's pressed, lock the box. So if we press that button, right, if it's pressed, lock the box. So if the switch value equals high, so if number 2 is getting electricity, if it's high, then say locked equals true. Change the status LEDs. So turn off the green LED, turn on the red LED, and then turn the servo 90, which is going to then turn the lock. Okay? And then print the box is locked. And then wait for the servo to move into position, and it's going to wait 1,000 milliseconds or 1 second. If the lock, so now if it is locked, right, check the value of the piezo. So it's going to check the value, right? Read the piezo, read what is coming into A0. If there are not enough valid knocks, so if the number of knocks is less than 3 and the knock value is more than 0, and then check if the knock is in range. So, and I'll talk about how this actually works in a second. If check for knock value is true, then add 1 to the number of knocks. Now, we'll walk through that in a minute. And then print the status. So then say serial print 3 minus the number of knocks. So there are however many more knocks to go. So I guess this one isn't as good as the video I'm sharing, actually. The video I'm sharing does have the code. This one's just looking for a certain number of knocks. So basically it's saying, hey, in this case, it looks like it's looking for 3 knocks. We'll see. Then it says if there are 3 knocks. So if there are 3 knocks, unlock the box. All right. The video I showed, it was more advanced than this. And so maybe I don't share the video until the end. We'll see. So all it's looking for is 3 knocks. So it's saying, hey, are the number of locks less than 3? And is the knock value more than 0? Well, then continue to check for the knocks. And then add 1 as it hears the knocks. Once there are 3 knocks, it's going to unlock. So then it's going to say it's false, turn the servo, wait 20 milliseconds, and then turn the green light on, the red light off, and then the box is unlocked. Okay? And then this one, this last one, let me get to in just a second. All right. Hi, I'm back. I had to get my students started, and they're so excited. We're actually doing this unit right now, and I was talking about a quadcopter I got, and it's not working. It's broken. The gimbal, the camera got broken off, and so I got this for free because it's completely useless. And so what I ended up being able to do is I took it apart and I found the problem, and it was a little connector on the motherboard, and I'm going to buy the part for 61 cents, $8 shipping, and I'm going to be able to fix it. So I'll make a video on that as well. Okay, let's get this one done. So we got through all of this. I believe we were just on this section. It says this function checks to see if a detected knock is within max and minimum range. So I believe this is just to make sure that it doesn't, like, say someone's walking through your house and it detects it. It just makes sure that it's hard enough, but not too hard, right? If someone's like hitting the door or whatever it is, they don't want it to open up, or you drop the box or something. So it's just checking those values. So it's saying if the value is more than the quiet knock, and less than the loud knock. So remember, we defined that up here somewhere. Right? 10 and 100. And you can sort of see those output values through your serial monitor. So if you're knocking and you're feeling like you have to knock really hard, change that 10 to a lower number. Or you feel like the banging, like it shouldn't count, change that 100 to a lower number. Or people walking around and setting it off, change that low number to a higher number. And so if the value is more than the quiet knock and less than the loud knock, then turn the yellow light on high, wait 50 milliseconds, and then turn the yellow light off. So every time it hears a knock, the yellow light's going to light up. And then it's going to say valid knock of value, and it'll tell you the value. All right, and then return true to the check for knock. So the check for knock will say true. If the knock is not within range, then say bad knock value and return false. So basically all we're doing on this one is 3 knocks that are loud enough and not too hard are going to turn that servo, unlocking your lock, right? And then 3 knocks is going to do the opposite, right? So it's pretty cool. I like it. I think the YouTube video does an even cooler one, and I will make sure to mention that in the description so no one's confused. So I hope this was good for you. I hope you learned something. I hope it meant something to you. I apologize. I disappeared and came back, but to you, you probably didn't even notice. So I am Mr. Duda with STEM with Mr. Duda. If you think there's anyone that could benefit from my videos, please share it with people. I really want to get this out to as many people as possible. I think these projects are awesome, and I've got a lot to share with people. So have a wonderful day, everybody, and thanks for doing this project with me. I'll see you later.